In my last video, I tried to build a Python script to find intrinsically undervalued stocks, and a lot of you correctly pointed out that the backtest wasn't exactly valid. The idea wasn't necessarily bad.
You sure about that?
But the backtest had flaws that were feeding us lies. So today I am implementing your suggestions to make iterative and continuous improvements to my code that determines the intrinsic value of a list of stocks and simulates a valid backtested portfolio to help me come to tested conclusions if intrinsic value is even correct to consider. This is a more long-term strategy, something I actually believe could work. But then again, I know nothing and I am reliant on your feedback to learn and grow my work. This is version 2 of the intrinsic value monitor. A quick note, this work comes from a physicist perspective, not somebody in finances, and as such I am greatly misinformed, uneducated, but I also have a fresh perspective on how to approach these problems. The original goal of this project was pretty simple. Take a list of stocks, estimate their intrinsic value using a very basic Graham-style formula, and then invest only when the market price is significantly below that estimate. You buy discounted companies, and then you sell once they revert back towards their fair value. But before we can even think about improving performance, we have to make sure that the model isn't accidentally lying to us. As always, this project is available on GitHub, where you can get access to my code repository and all future versions of the code as I continue to improve it. All money that I'm making from GitHub sponsors is going to go directly to paying my fucking $100,000 of student loans. Let's go! And that brings us into why the original backtest was invalid. In the original version, the backtest scanned a list of stock tickers that exist today, and that's a massive problem. Because over 30, 40, 50 years, companies have gone bankrupt, been acquired, delisted, or disappeared entirely. And by only testing companies that survive today, I was implicitly assuming that every investment had a happy ending, which is obviously not true. This is a super simple thing to avoid. It is survivorship bias.
You'd have to test this on the historical constituents of the S&P 500, including delisted stocks, for this to be even remotely valid. If you only test tickers that are in the S&P 500 today, then you have survivor bias.
Well, maybe it's easy to recognize, actually quite difficult to avoid. So comparing my backtest to a historical S&P return, I may have actually had inflated results, higher returns than reality, and convinced myself that the model might work when it doesn't. So let's get into survivorship bias. Fixing this was actually not as easy as I initially expected. I pulled Discord members, searched around online, and quickly realized that there really isn't a clean, publicly available solution. I ended up boiling this problem down into a few broad categories. I could use full point-in-time market databases, which is really the gold standard. I could use something like the CRSP, which is the Center for Research and Security prices, and these datasets track all listed securities, delistings, bankruptcies, and acquisitions. It's basically the index membership at each point in time. Additionally, all fundamentals are reported as the originals, so there's no look-ahead bias. The problem with this is that even if I could access the data, I can't legally redistribute it. The entire goal of this project, and really my channel in general, is to keep all the code I create open source and reproducible, and that immediately rules out proprietary datasets. So this one is completely off the table. Then there's index reconstruction, which is actually what I'm going to attempt here, which is to use publicly available S&P membership change logs. We reconstruct the index through time using entry and removal dates, and at any point in time during the backtest, I allow investments in stocks that were valid members at that time. There's some pretty big limitations, as we'll quickly realize. For example, reconstructing this membership accurately is definitely non-trivial. It is difficult. It does not perfectly account for companies removed due to acquisitions or companies that disappeared entirely, and there still is some survivorship bias that can leak through depending on data quality and assumptions. Another option was the broad market universe, which is all stocks listed at a time t, which I feel like I have to mention because somebody is going to say something about this. The concept is to define the investment universe as every stock listed on an exchange at that point in time, and there's a bunch of problems with this. Primarily that there's massive complexity very early in this project, and there's still so many things that we need to take care of. So trying to even tackle that concept in advance is way too much. I'm only one guy, please don't do it to me. This would require reliable delistings and historical listings data, which I do not have, and many publicly available data sets still contain survivorship bias, especially on fundamentals. So I decided to go with this temporary fix of number 2, which is index reconstruction, specifically reconstructing the S&P 500 membership. This is one that may work for the time being since there's just so much to improve on in this code. It's important we don't get too carried away with completely eliminating survivorship bias immediately. I decided to take publicly available data for the S&P 500 membership, when stocks were added and when they were removed. I recreated a list based on this information, and I only used this recreated membership list to choose what stocks to invest in. So at any point in time during the backtest, I am pulling the currently acceptable members from that list. If a stock hasn't been added yet, I don't use it. If a stock was just removed for whatever reason, I'm no longer allowed to use it. This is, I feel, a realistic representation of what someone could have invested in. This guarantees that I'm not selecting tickers that didn't exist yet, but it does not guarantee that survivorship bias is fully eliminated. There are a couple issues with doing this, primarily that survivorship bias is not completely eliminated, and I actually have not perfectly reconstructed the S&P 500. And no matter how hard I try, I don't even have 500 stocks in the membership list as a function of time. Some stocks have been missed, and those stocks could have been bad performers for whatever reason, meaning that the list is biased high. I've selected higher performers than I would have if I truly had a representative sample of the S&P 500 in time. So how do I mitigate for this? Well, instead of comparing to the S&P 500 index, which would be unfair, I compare my strategy to a naive baseline built from the same universe. The baseline is an equal weighted portfolio of all eligible constituents at each point in time. It happens to be higher than the actual S&P 500, so yes, my membership bias list is biased high, and I'm missing stocks in this list that performed poorly, and having an equal weighting of all companies in the list that I do have is not consistent with what the S&P actually was, but this is the best bet that I have right now because keeping track of weightings is just really not possible for me. But my comparisons will be made to this evenly weighted membership return, the one that I have synthetically created myself. Meaning that if I bought an equal price of each stock in my list and held it for the entire duration, which basically means, what if I bought an equal price of each stock in my list and held it for an entire duration that I've determined for my backtest? If a company is removed from the membership list, I just rebalance the portfolio accordingly such that it's evenly weighted across all members. This is super crude, but if my method outperforms the baseline, then we will try to make this a little bit more robust. But there's no point in trying to make a perfect non-biased data set with no survivorship bias if my model can even outperform that crude baseline.
What were the exact data sources used in the backtest? And were they point-in-time or revised historical data?
Another problem was point-in-time data errors. And this is subtle, but can be just as damaging. It's effectively look-ahead bias. When we pull historical financial data, what we actually get is revised data. It's been cleaned up with information that wasn't known at that time. That means that the model can accidentally use future earnings or corrected reports before investors actually saw them. That is look-ahead bias, and it can completely invalidate a backtest. So I implement a conservative reporting lag, which I know you guys are gonna absolutely hate, but bear with me here. This is intentionally conservative, and instead of trying to perfectly model reporting dates, I assume that financial data becomes usable 90 days after the quarter ends. That means that the model is always late, but this model is meant to be long-term, so that should be fine. We are avoiding some complexity in doing this, which sure makes our lives easier, but it makes it more difficult for the model to outperform the market. Since we plan to use this code for long-term investments, hoping to latch on to broad market swings due to changes in sentiment, I think that this is a fine conservatism to make, at least for now. We just need to make a point of this in the future in case we want to revisit this and improve the method. Once you apply these two corrections, results usually get worse. Drawdowns increase, some strategies just stop working entirely, and yeah, maybe mine gets worse, but that's actually kind of the point. Any model that collapses when you remove bias wasn't discovering anything. It was probably discovering data leakage, but we do need a good baseline to work from. From here, the plan is simple, but it is slow. We're gonna build honestly, break things, fix them, create multiple indicators for intrinsic value, and weight them according to the domain of highest accuracy. Some next steps might include building better intrinsic value models, quality filters, smarter exits, or risk control, but only after the foundation is rock solid. If you guys have ideas, criticisms, or flaws you want me to address in the next video, please leave them in the comments below. If you're interested in getting access to the code, you can find it in the link in the description. I hope to see you guys in the next iteration in version 3, where I plan to improve my code to potentially automate my finances and increase my abysmal net worth. I'll see you guys in the next one.